Okay, this is the Laws of Indices solutions. And in the first question, we see just a fact that we have to know. Anything to the power of 0, anything to the power of 0 equals 1. So I have 6 times something to the power of 0. 6 times 1, and that's just 6. Now in the next question, this one is here because we actually don't need laws of indices for it, but a lot of people think you do. This is just collecting like terms. 5 times something minus 3 times something, that is simply 2 times something. You don't need to do anything with the powers. We are just collecting like terms. Remember, if we're adding or subtracting, it's just going to be collecting like terms. This is very different, of course, to the next question, where we are multiplying. And this one we are going to need our laws of indices. Now, 3 times 5, let's do the numbers first. 3 times 5 is 15. Now I have y to the 6 times y to the minus 2. If we multiply the y's, we're going to add their powers. 6 add negative 2, and that's going to give me y to the power of 4. And that is what goes with our 15. In the next question, I'm going to use that same rule again. If I multiply these 2's, I'm going to add their powers. So this is 2 to the power of minus 4, add 5. And that is 2 to the power of 1. A common mistake here is to think I also have to do 2 times 2, which of course would be 4. That is not correct. Okay, just as y to the power of 6 times y to the power of minus 2 ended up being y to the power of something, 2 to the power of minus 4 times 2 to the 5 ends up being 2 to the something. In the next question, we've got m to the power of 5 squared. A power of a power multiplies. This is m to the power of 5 times 2. And that is m to the power of 10. A power of a power multiplies. So our next question is a slightly bigger version of what we did up here. Once again, I'm going to split things up so that everything that's relevant is being multiplied in each stage. 4 times 5, 20. X cubed times x squared. If I multiply the x's, I add their powers. 3 plus 2 is 5. This is x to the power of 5. Now y times y is y squared. And there's our answer. For the next question, we remember what we did for the first question. Anything to the power of 0 equals 1. Here's a very easy multiplication. If I multiply the y's, I add their powers. 4 plus 5 is 9. This is y to the power of 9. Now over here I see something where I'm adding and subtracting. And I have to remember this doesn't use the laws of indices. This is simple. 8p plus 4p is 12p. And carefully on a calculator, because it involves negative numbers, you would do plus 2r minus 9r to get minus 7r. Don't fall into the trap. Often, questions involving collecting terms will be put right next to questions using laws of indices. Don't make the mistake of thinking that they work the same way. So here I have a multiplication. 4 times 6 is 24. And x cubed times x squared, if I multiply the x's, I add their powers, x to the power of 5. And here we go with some more. Remember what we said before? Power of a power multiplies. This is w to the 5 times 2, w to the 10. If I multiply the m's, I add their powers, m to the power of 9. Now here's one we haven't done yet on this worksheet. When I multiply, I add powers. When I divide, I subtract powers. This is p to the power of 8 minus 2, which is p to the power of 6. Now this question over here, we have to be a little bit careful, because we have not only the letter to the power of 4, but we also have a 2 to the power of 4, and we have to do both of them. So 2 to the power of 4 we can do on the calculator, and that comes out as 16. And then n cubed to the power of 4, power of a power multiplies. So this becomes n to the power of 3 times 4, n to the power of 12. Now I have to simplify a division. Remember what we said up here? If we divide our letters, we subtract their powers. So this is m to the power of 5 minus 3, m to the power of 2. Here's yet another big multiplication. Now this one is a little bit different because this 5 has nothing to multiply with over there, so it's just 5 still. X to the power of 4 times x squared, if I times the x's, I add their powers, so that's 4 plus 2 is 6, x to the power of 6. And then I have y cubed times y, which is secretly, of course, y to the power of 1. If I multiply the y's, I add their powers, and 3 plus 1 is 4, y to the power of 4. Now we have a couple of questions which are a little bit harder. They involve an element of equation solving. So equation solving we've broken down before, and what it essentially comes down to is simplifying until the answer is fairly easy to work out. Simplifying in these sorts of questions will mean using our laws of indices to write these things in a tidier fashion. So let's look at this side over here. If I multiply the 7's, I add their powers. This is 7 to the power of 5 plus 6, 7 to the power of 11. Now if I multiply these 7's, I also add their powers. And don't be put off because one of them is a letter. 7 to the 3 plus k. Remember, multiplying the 7's doesn't mean I have to do 7 times 7, because they have powers, it just means I have to add their powers, like we discussed before. Now look at this thing we've figured out here. 7 to the power of 11 equals 7 to the power of 3 plus something. So really what we're dealing with here is very simple. I need that 11 on the left-hand side to be the same as the 3 plus something on the right-hand side. And so it's pretty easy to see that k must equal 8. Now, let's have a look at the next one. I'm being asked to solve 3 to the power of 7 divided by 3 to the power of x equals 9. This one is really a little bit trickier than the last one. First of all, I can use my laws of indices over here and say this is 3 to the power of 7 minus x. If I divide the 3's, I subtract their powers. And that has to equal 9. Now what we got to do up here in question 11 was say, well, 7 to the power of this equals 7 to the power of that. So it's pretty obvious that this must equal that. And that's what I did. 7 to the power of this equals 7 to the power of that. So this, the 11, equals that, the 3 plus k. And we could solve that equation. But now I don't seem to have this situation. I've got 3 to the power of something equals 9. I don't have any of this 7 to the this, 7 to that thing going on. But remember, 9 is 3 squared. Okay? 3 to the power of this equals 3 to the power of that, which is really very sneaky. 7 minus x must equal 2. 7 minus something equals 2, so that something must be 5. Now we're going to use a similar trick to do the final question. We can see 5 to the power of something over here, and 5 to the power of something over there, and then 25 is the odd man out. But if we know a little bit about our square numbers, we know 25 is 5 squared. So that can be written down as 5 to the power of something as well, and that's going to make our life easier. 5 to the power of x divided by 5 to the power of 2 instead of 25 equals 5 to the power of 6. Remember your laws of indices, if we divide the 5s, we subtract their powers. This is 5 to the power of x minus 2 equals 5 to the power of 6. 5 to the power of this equals 5 to the power of that, so this equals that. And that's giving me x equals 8 for my solution. So these last two questions are quite a bit more difficult than the other questions on the sheet. The way that we deal with them is by spotting the odd one out. 3 to the power of something divided by 3 to the power of something equals 9. Well, that's clearly the odd one out. And we can write 9 as 3 to the power of 2 and use our laws of indices. And this equals that principle that we saw over here. The same thing is going on with this question. 5 to the power of x divided by something equals 5 to the power of 6. Well, this something is the odd one out and must be dealt with. It's 5 to the power of 2. I can use my laws of indices and then use the this equals that idea to solve my equation. And those are all the solutions for this worksheet.